This problem is a fancy way of just saying to find the range. Now, a lot of people are familiar with domain and range with respect to functions, but we're trying to find the range of this function. And the range of any function is just the set of all valid outputs. The domain is the set of all valid inputs. Okay, now notice the form this is in. You have something squared plus that same something divided by a constant almost. Okay, so that leads us to a justification of something called complete the square. And I wanted to write this down. Some people just do it in their heads when they're doing the videos, and that's me most of the time. But this is a justification for this idea of complete the square. See, if you take this thing and split it in two, it's equal to this minus this squared. And again, you can expand this out and see that this is true, but this is hopefully a simple justification of the complete the square process. And again, this is almost in this form. This here is a logarithm function squared minus almost, the same thing squared, and we'll make an adjustment for that as you see. All right, now, so what we can do here is actually get this get what we're interested in this form rather quickly. Now, I didn't write down the justification right here, but I'm sure a lot of you see that this term right here, well, I'll just write it down. And I'll drop the 10 because when you drop the base, it's understood to be 10. But this is the same thing as log of x to the 1/3. Okay? And folks, again, I'm talking about only the numerator here, right? So, but a very easy to prove and well-known result for logarithms says this exponent can just drift around to the front, become a multiplier or a factor. So you have this is equal to 1/3, and that's based on the multiplication property for exponents. It all follows immediately from stuff about exponents, exponential functions, okay? So you can see what happened. This 3 dropped down here. 3 times 4 is the 12 that you see right here, okay? Now this puts us in a position, now it is definitely in this form, right? This part right here is exactly in this form, right? After applying this law of logarithms. Okay, so that's kind of cool. And that means we can just apply this complete the square. I'll call this CTS if you want. Again, in competitions, the hardened competitors just know how to do this so fast in their heads they don't need, but this is the generic structure of the complete the square process. All right, now, so here we go, and I won't say much now. This is exactly what we just talked about up here. Okay, so not much to say, it's all written down. Now, and so we get this minus 1 over 576. So that right there, as long as this part can be equal to 0, is going to be our local or our absolute minimum value, which means our range will be every number greater than or equal to minus 1 over 576. Okay, but and again, we're effectively done right now. But let's just take a look at when this happens. This part would have to be equal to 0, right? So you would have to have log base 10 of x minus 1 over 24 equal to 0. Okay, now, so that's equivalent to saying log base 10 of x is equal to 1 over 24. And of course, folks, every logarithmic statement is just an exponential statement in drag. All right, so you can write this as x is equal to 10 to the 1/24. And of course, another way to write this, a lot of people don't like this for some reason, is use the radical notation with the index of the radical being 24. Put a 10 here. Now again, if you're not familiar with this notation, just think of this being 10 to the first and 24, and that's just the connection. That's literally a definitional thing. Okay, but in any event, the range of this function, the original function, is going to be always greater than or equal to, this m would be minus 1 over 576. And again, that is definitely what some people call it absolute. I've seen it called global. But that's the answer, folks. The range of the function. And some people, if you want to think of ranges in a set theoretic way, the range would be minus 1 over 576 to infinity. Of course, infinity is not a number, so you have to put parens there. So that's the range of the function, folks. So I think that does it, and all is well. Thanks for viewing.